Hello all. Now we are going to discuss about the project e-commerce shipping prediction using machine learning. Now coming to the coding part, first we have to import unnecessary libraries such as NumPy and Pandas and Matplotlib and cbom for data visualization. First we have to read the dataset. For that we are using the command pd.readcsv. Then we can get the dataset like this with the attributes id, warehouse deck and etc. Next we are going to read the first 5 rows of the dataset using df.head function. Next, to read the last five rows of the dataset, we can use the df.tail function. And for the shape of the data frame, we can use data.shape, and using df.info we can describe the dataset using df.describe. And we can handle the null values by the following commands. And we can handle the categorical data by using the following functions, and we can treat the outliers in the dataset by using boxplot and subplot, etc. Here are the you can see the boxplot and the subplot for the outlier treatment, and simply we can check the outliers by creating a function and naming it as upper and lower bound. And next we can split the data into training and testing. When we are performing data validation on the dataset, we can see the data visualization here. Next we have to build a machine learning model using scikit-learn library. Next we are doing the normalization and testing the model by using random forest, logistic regression and XGBoost. Here we can see the performance testing and hyperparameter tuning. First we have to compare the model by using different evaluation metrics, and here we can see the different evaluation metrics like logistic regression and logistic regression CV, XGBoost, rigid classifier, KNN, random forest and support vector machine. And the attributes accuracy, F1 score, recall, precision is given according to the rows. Next we have to compare the model accuracy before and after applying the hyperparameter tuning. For that we are hyperparameter tuning, we are using XGBoost. Here are the XGBoost parameters. Next, random forest parameters. Next, logistic regression parameters and hyperparameter operation for XGBoost. We are performing the hyperparameter optimization. Here we can see the best score for XGBoost is 0.68, that is 68%, and for logistic regression that is 0.64, that is 64%, and hyperparameter optimization for random forest we have performed, and the best score is 0.68, that is 68%. And hyperparameter optimization for SVM we have performed, and we can see the score of 0.61, that is 61%. Next we have to deploy the model into web application. For that we are using library called pickle and saving our model by using the pickle.dump. And next we have to integrate our model with web framework by using Flask library. Here we can see the code for app and deployment machines. Next we can see the web page by running this code. Hello all, welcome to the app building and web integrating with the web framework. Now we can see the app VY code for our machine learning model, and we are importing pickle library to save our model with web framework, and at the same time we are constructing a HTML page for our web application, and we are adding some styles to our web application. To work in the background, we are using JavaScript functions. And when we run this code, it will redirect to a web application in which we can give our values to predict the shipping prediction of our delivery time. Here we can see the static CSS. These are the templates that are required to construct a web application. So next we can see the proper implementation of this code. Now we are going to showcase the web application which we have built. By using localhost 4000 we can get our HTML page like this, in which we have to provide warehouse block, mode of shipment, customer care sale cars, customer rating, cost of the product, prior purchases. If we enter the similar attributes like product importance, gender, discount offered, weight in grams, we can get our estimated time of delivery like this. Thank you for giving this opportunity. I hope this really helps you a lot to find the endeavors in the future machine learning projects. Thank you for giving us the opportunity.